Justin Castile. Hey, how's it going? Justin here with Redis University. Today we're going to be covering how to cache API responses. Now, if you're new to caching, you want to check out the first two videos that I produced called What is Caching and How to Cache Slow Database Queries. They give you a really good rundown on the motivation behind caching and how to implement that with Redis. But for today, we're going to actually contact a third-party API and cache the results. We'll see a huge speed up in response time for our client, and we'll also save a lot of money or bandwidth by not contacting the third party as much. So let's get started. All right, so now I'm going to start absolutely fresh. So I'm going to make a directory called API caching. And within the API caching, I'm going to init a new node project. And I'm just going to press enter here for speed. Again, this is just hacking really quick how to demonstrate how to cache. So I'm not really too concerned with housekeeping. Looks great. All right, I'm going to install Axios and ioredis. Axios allows me to make HTTP requests to a URL, and ioredis is my preferred client for JavaScript. So let's also touch api.js. This is going to be the file that I'm going to be working with and running my example code. All right, and let's open it up. All right, so now I have my api.js file. This is going to be where I write all of my code. I'm going to go to package.json and do type:\module. This will allow me to write ES6 within my api.js file. All right, so I'm going to start with import axios from axios. And this is going to allow me to use my third-party library to actually make HTTP requests to my API source. All right, so this is going to be a little bit of a big one, but I'm going to create a variable called city endpoint, and I'm going to reach this endpoint. It's actually going to be a function that I'm going to pass in a city as a parameter, and it's just going to be an interpolated string. So HTTP API, and we're actually going to use openweathermap.org, which is a great resource for playing around with contacting APIs and getting data back. It is, as you guessed, a weather resource, and we can actually say, hey, I'm in a certain city, and I would like to get some information back from that city, mainly weather. And I'll want to get the units back in imperial instead of metric. And I want to give you my app ID. Now, my app ID is going to be, yes, the API key. So each user is going to get their own key. So you can actually go to openweathermap.org and get a free API key. So you can actually code along and play and find the weather in your own location. So here I'm going to actually enter my own weather API key, and I actually put that as an environment and variable, and that's a good practice. So weather API key. And now this is a big long string, but basically this returns a custom endpoint with my API key and a city of my choice. So I'm going to use Oakland in this example, but you can use any city that you want. All right, so now I'm going to create a function called getWeather, which does what it does, it gets weather. And I'm going to actually pass in the city name into this function, which will then in turn pass it into city endpoint. So let's start here by just getting a simple API response. And I'll use Axios, I'll use the get method, and I'll pass in my city endpoint function, and I'll pass in whatever city I want. This will be Oakland again, and I'll call that later on when I'm done coding out the function. Cool. All right. And then finally, I will return an object. Now I'm going to return a JSON object because that's really great to work with, especially with the client, the front-end client. So I'm going to send back the API response .data because I know that .data is the payload that I want from Axios for my return from OpenWeatherMap. Now I also want to tack on where I received this information. So I'm going to have source : API. And you'll see why we do that a little bit later on. All right, so I'll call that good for my just getting started function. Really, all I want to do now is demonstrate that I can get data from openweathermap.org. All right, and I also want to get some timing to find out how fast that is, but I'll do that in a little bit. But first I want to do baby steps. So city equals Oakland. And then I'll create a variable called weather. And let's call getWeather. I'll pass in our city. And then finally, I'll console.log weather. So now I will go here and call api.js with node. And there we go. So here is the JSON response from openweathermap.org. And here's the coordinates that it has for Oakland. Here's the weather. There's clouds, overcast clouds. I can verify that. It says the temp is 20.14. That must be in the Celsius. Hey Alexa, what's 20.14 Celsius in Fahrenheit?
20.14 degrees Celsius is 68.252 degrees Fahrenheit.
That tracks. Thank you. Cool. So we definitely know that we are contacting our third-party API. That's fantastic. This is a core fundamental skill to have as a developer, and we did it. So not too amazing for those that have done this before, but this is a really great first step. Also, you'll see that I have the source API. This is telling me that it's coming from the API, and this is, I actually put this into my JSON object right here, and that will be a little bit more interesting later on. Cool. So now let's do some timing. I want to know how long it's going to take for me to contact that API and for data to come back. So I'll do const. Now I'm going to set two timers up, or two timestamps basically. And I'll find the difference between the two, and that will be how long it takes for this function to process. So I'll take const t0 equals new date get time. And then I'll let weather call. And then down here, I'm going to call const t1 equals new date dot get time. Now this is creating two time objects. And what I want to do is I want to place the difference between those two time objects in my weather JSON response. And that'll tell me how long in milliseconds it took for that function to process. So let's do weather.response-time equals, and I'm going to use string interpolation again. And I'm going to take t1, subtract t0, and tack on milliseconds at the end, just so I know how long it's going to take. All right, let me call this again. All right, cool. So now here's the source that I added manually, and now we have response time, 179 milliseconds for us to contact the third-party API and for it to come back with that information. Now, that's going to be really important later on. So let's continue. So now we actually have us contacting a third-party API. Now I want to cache our responses, and I want to cache them for an hour. And just a hint as far as what we're going to be doing. I'll explain why, but that's actually really, really important as well. So I'm going to call import Redis from ioredis. And this is going to be the client that I use to actually contact my local Redis on my machine. So we need to do some overhead to actually connect to Redis. So const Redis equals, oh, actually, you know what? I'm going to capitalize this because this is an object that I'm creating. So Redis, pass in a couple options. I'm going to put in port. 6379 is the default. And then host is going to be 127.0.0.1. All right. So this is actually going to connect to my local Redis instance so I can actually store and retrieve information from my Redis. All right, cool. So let's actually run my file one more time just to make sure everything's great. No complaints. Oh, okay. I have some complaints. Now what is this? Error, connect, econ refused, 127.0.0.1.6379. ioredis. Okay. So that means that it's not actually connecting properly to my Redis. That's not a problem at all. I actually have an image for Redis 6 loaded in my Docker desktop. I'll just run that. And there we go. We know the image is now running. Let me run this again just to make sure. Okay, cool. No complaints. I love it. All right, so now I am ready to actually use my Redis. So here we are calling API for response. What we want to do is check if we have a cached value of the city weather we want. So basically, we're going to check our local Redis instance for a copy of that JSON object before we actually contact a third-party API. And I'll talk a little bit after we code this out as far as why we will actually want to do that. So I want to look for a cache entry within my Redis. So I'm going to create a variable called cache entry. And I'm going to try to find in my Redis instance, I'm going to get a key. Now I'm going to name all my keys beginning with weather, and then the actual city. Key naming conventions are extremely important when you're working with Redis because that way you can keep everything organized. You know exactly how to find an instance within your Redis cache if it does exist. So here I am looking at weather city. So in this case, if I call this again, it's going to try to look for weather Oakland. All right. All right. So now we're trying to find our instance of our cache entry. So if we have a cache hit, that is, if we actually have an instance of that JSON object within our Redis, then we'll return that entry. Otherwise, we're calling the API for the actual response. So you see, we're checking locally if we have that object. If not, then we're going to actually contact Open Weather Map. And this just saves us time and them usage on their computers. So if we have a cache hit, so if cache entry, so if we actually have a copy of that data within our cache, then that's called a cache hit. That's important. We have cache hits, we have cache misses. So with the cache hit, I'm going to take out that cache entry and I'm going to parse it back into JSON, just so it's easier for us to see, because I'm actually going to be storing these as strings within Redis. And then since, got to put this back in the if clause, since this is actually a successful find within our Redis cache, then I'll return the cache entry. And then I'll also include the source, but instead of API down here, I'm actually going to have source cache. So now we can actually see where it's coming from. Gotta finish out my ellipses. So now I have two possible outcomes for when we look for a cache entry. Or I'm sorry, when we look for an actual piece of information for a city's weather. If there is an actual cache entry within my Redis, then we're going to return that actual cache entry. If there is not a cache entry, then we must have a cache miss. And we are calling an API for a response. I'm going to call Open Weather Map, and they will send me that data, and I'll have it as a source for API. Cool. So this isn't going to do a whole lot because we're not going to have a cache entry, but I think it's worth running just as a quick little sanity check. Cool. Everything runs. All right. And I'm also going to add just at the end process.exit because I like everything ending gracefully. Totally forgot about that. All right. So it is looking for a cache entry. I have no cache entries because I haven't placed anything into the Redis cache yet. So we're going to be doing that now. So once I have an API response, that means that I have a piece of JSON that I can store in my cache. So I'll call redis.set. Remember, we have get and set. So set is creating an entry, and I'm going to use string interpolation again. And I'm going to place the city in there. This is me creating the key. Here I was looking for the key, and here I am creating the key, and it's just a convention that we follow. And I'm also going to place the actual value in here. So right now it's in JSON. I'm going to turn it into a string. So stringify API response. And with axios, I call API response.data. And now that's going to have my actual value set inside Redis. Cool. So let's go ahead and check that out. So I'm going to run this one more time, and I'm expecting it to come from API because I did look in the cache, but it's not in there yet. Now, since we did receive a response from Open Weather Map, we're also setting it inside Redis. So hopefully with weather::Oakland, I should see a cached value. Okay, so let's give that a try again. Wow. Okay, cool. So we have source cache, which means that it actually came from our local Redis instance. But look at the response time. 8 milliseconds. What was the last response time from the API? 199 milliseconds. Holy Toledo. Now, can I repeat this? Is this just a fluke? No, it's very fast. 8 milliseconds, 7 milliseconds, 8 milliseconds. That's really fast. That's pretty amazing. Let's try passing it a second city just to make sure everything works. So let's look at Seattle. And the first time it's going to look for Seattle, it's going to have a cache miss. Okay, so now it's looking at the API and it took 182 milliseconds. Now let's run that again. Hopefully it'll have recorded the Seattle JSON object in our Redis. So let's give it another try. There we go. 8 milliseconds. Cool. So now we have all of this data cached. Now, one small little detail with cache is that caching can become stale. So it was 68 degrees in Oakland. Will Oakland stay 68 degrees all the time? No. I mean, it would be pretty nice. It does get hot here during the summer, but no, the weather will change. So we actually want to invalidate that cache entry after a certain amount of time. Now with weather, I would say we could see a significant change in weather within an hour. So I want this key to be invalidated or deleted after an hour. With Redis, we have an EX option that allows us to expire that key after a certain amount of time. So I want to actually expire it after an hour. That means after an hour of me first checking the weather of Oakland, after it is cached, it will go away. So I will have to check the API third-party vendor again to get the most up-to-date information. Now, that might seem counterintuitive to caching, but we want to ensure that our cache is fresh, not stale. You might hear that sometimes. So we want to have a fresh cache. We want to make sure that the weather is up-to-date and relevant as well. So we'll go on to further into the motivations of this later on down the line, but for now, I just wanted to stop and just sort of figure out why we're doing that and how to do that. So it's really, really quite easy with Redis. We want to set an expiration date. So we'll use the keyword EX, and then I'm going to do an hour. I'm sorry, I'm going to put this in quotes. An hour in seconds. So 3,600 seconds equals an hour. Cool. So are we going to see any significant change? No, we're not going to see any change at all. But what I do need to do is go into my Redis command line interface. I'm going to look at my keys. Now I have two entries, weather::Oakland and weather::Seattle. I don't really want these in here because they don't have the expiration anymore. So what I want to do is I'm going to call flushdb. This is very dangerous if you're running a production version of Redis. This is just a fun little sandbox version. So flushdb, I'll call keys again to look at all my keys, and I have no keys. Also, keys is considered dangerous because you can see a lot of information that you're not supposed to see. Also, it could really bog down your Redis instance if you have tons and tons and terabytes of keys and data. So let's just not use those unless you're just playing in a sandbox like we are right now. So, okay, I have an empty database, which is great. So now when I run a caching instance, I will actually set an expiration. So let me run node API.js. I looked up Seattle again. It took 177 milliseconds, so I know it's from the API. I'll run this again, and now it's 9 milliseconds. So now I know I have a cached entry. So what I can do to actually check, what am I doing? If I have an expiration date, is I'll call the TTL command. TTL, or time to live, allows me to check how long a certain key has to live. So I'm going to check TTL weather : Seattle. And there we go. 3,569 seconds left. So that's a little bit under an hour. So now I can verify that that's actually going to stay in my Redis instance until an hour passes, and then it will be deleted. Cool. So that's actually the bare minimum to get a caching instance running for your third-party APIs. Now, the question that might come up is, why would you still want to do that? How often do people actually use the same data? Well, quite a lot. If I'm having an interesting weather event, say like a big downpour of rain or some crazy wind going on, and I look up the weather in Oakland, well, the odds are other people in Oakland are also going to be looking up that same data. So when you have that data cached, instead of me having to contact a third-party API, I have it encapsulated within my Redis instance. And I can send it, like you see, instead of requesting it for 200 milliseconds on average, I can send it in 8 or 7 milliseconds. So it's a huge speed up. Cool. So this is a little rough and tumble, but I'll also have a nice cleaned up version of this code example up on GitHub for you to check out. And as always, feel free to hit me up on our Discord channel or on Twitter or anywhere that you on our YouTube channel, and let me know what you think. If you have any questions about the caching example, I'm more than happy to answer any questions. This is going to be on YouTube, so make sure to please subscribe. We're really excited to bring all this content to you. We really want to know what you think about what we're doing. I want to make sure that we're doing everything right, and I want to know what you want to see from us so we can actually continue to deliver good content. Cool? All right. Well, thank you very much for joining, and I hope to talk to you soon.